Alright, we are doing factorization today, as you can see by the title. What we have done so far, what you just got tested on yesterday, was called expansion. And what did you do with expansion? It removed the brackets from an expression. A skill you need for later maths is called factorization, which is literally the reverse of that. So you're just doing it backwards. Factorization puts the brackets back and shows the factors of the expression. What is a factor? I cannot just assume that you know what a factor is. So I need to show you what a factor is. A factor is any number that you multiply to get a product. So if my product is 8, what numbers can I times together to get 8? What numbers?
2 and 4.
2 and 4 is one set of factors. 2,
8 and 1.
4, 8, 1. You're in the back. You got the single. Huh? Good luck. You have a cheat sheet? Where is it? Okay, good. Get it out. You got the single. Don't waste time. Get the headphones on so you can't hear this. The first type of factorization we learned is common factors factorization. You may remember from yesterday, I taught you something called distributive law, but it was the other way around. You had A bracket B plus C equals AB plus AC. So all you are doing today is distributive law, but backwards. So remember, just the black is notes to help me teach it to you. What you really need is the stuff in blue. I like that you're trying to get everything that I say down. That's awesome. But the stuff that's vital, because we're young people these days in 2024, and you want to do as little work as possible, I try to show you that the blue is the main thing that you need, okay? So what is common factors factorization? This is what should go on your cheat sheet. AB plus AC equals, suddenly the brackets come back. A in brackets B plus C. So what are the steps? Just a little reminder here. When you're factorizing, we often use a dot to represent multiplication. Any idea why we might do that? Why might we do little dots instead of the cross for multiplication? Yes?
Saving space.
Saving space is one, yes?
It doesn't get confusing with like other x.
Yes, good, because if you had, I don't know, 4x to the power of 3, and you wanted to write that as factors, if you wrote multiplication as your little x, it's going to look like this: 4 times by x times by x times by x. And I think you would agree that that could get confusing depending on how you write your x's and how fast you would go. Okay, so instead we might write that so you don't confuse the times, okay? That's just a side note. You don't need to, that's not a vital thing that you need to remember for the test or anything. That's just to help us with writing this. So what are the steps in common factors factorization? Break the terms down into factors. What would I have to times together to get 2x squared? Help me out. What don't we write between numbers and variables? The times sign. So 2x squared is going to be 2.x. How do I get x squared? What do I times together to get x squared? X again, good. See how we broke this 2x squared down into, I times 2 by x and another x. Plus, what things could I break 6x into? 6.x, but let's be smart about it because I've got a 2 here. What do I times 2 by to get 6? Good. So I can break it down into 3.2 x, and hopefully you agree with me that 3 times by 2, does that get you 6? And if I times 6 by x, does that give you 6x?
Yes.
I've factorized it down. Can I give you a couple, like a minute or so? Can you get that? Break the terms down into factors and e.g. Do you all know what e.g. means? It's like for example. Okay? It's like a short version of that. So just get step 1 down. Break the terms down into factors and the little bit in red that shows you how that works. We'll do more examples on the board next. So only the stuff in yellow. Only the stuff in yellow is relevant. You can't do any of it? Is this your cheat sheet? All right, let me demonstrate step 2. I didn't mean to have the cheat sheet fall down, but I'm trying to teach a lesson here. Put the highest common factor on the left outside a set of brackets. If you look here, in these two separate things, what's the biggest chunk that's in both? Is 2 the biggest?
3.
But it's not in both.
X.
Getting closer. Is there a 2 in both? Is there also an x in both? Do I have a 2x and a 2x right next to each other? So you could say that 2 is in both, but that's not the biggest factor. What's the biggest factor that I can get out of this? 2x is in one of those, and 2x is in the other. So according to this step, put the highest common factor on the left outside a set of brackets. So I'll go 2x was the highest common factor, and I'll just have a set of brackets empty here. Okay? Where did the 2x come from? It was the highest common thing in both. So a minute or so, can you get the step 2 down and then the example in red? Alright, and then demo the last step, which is put the leftover factors inside the brackets. Question? What? Okay, good. Okay, so we've moved 2x to the outside. So it's on the outside. What's left over in the little factorization that can go inside? What's left over that's not in those boxes? Excellent. 2x, x plus 3. Can you see how these are left over in the middle? And I remove 2x and put in both. And now call me a liar. You can tell me, Mr. T, that's not the reverse of distributive yaw. Yes, it is. Because what's on the outside here? 2x. And if I wanted to do distributive law, I'd go 2x times by x, which gives you 2x squared. Now I'm going to times that with the second one. What's 2x times by 3? Well done. Please, make sure you get those 3 steps down. Those are probably what you would need on your cheat sheet if you bother to write one. Let's do some harder examples. Let's practice doing those 3 steps on harder and harder examples. You're probably looking at these and freaking out, but then I'll calm you down and you'll be like, no, it just looks harder. This looks similar to what we just did there. Someone other than that table there is listening. What could I break this down into? What numbers can I multiply to get 6x squared? What numbers can I get? Yeah.
6 and 4. No, 2 and 4.
Closer. 2 and? What do I times together to get?
1, 2, and 3.
Good. So 6x could be 2, 3 times by 2 times by x. What do I times x by to get x squared? X again. So we've broken this down into 4 things. Plus. Someone else, what do I times together to get 4x? Good. 2 and another 2 times by. We're breaking it down into little chunks there. What's the biggest chunk in each of those things, either side of the plus, that's in both of them?
2x.
Well done. So put a box around it. What happens to that thing that we chucked in the box? Where does it go? At the start. So now we go equals 2x, goes on the outside of the brackets, and then on there over here. What's left over? What's not in a box that's left here?
3x plus 2.
Excellent. If you want to cross things out, you can do that if you want. So you can see what's left over. There's a 3 times by an x left over, that's why it goes there. And a 2. Can you get that example down, please? Alright, some of you are probably looking at this one and going, this resembles nothing that you have shown me. Yeah, it does. What sign do we leave out in algebra? Times. And what have I suggested that you write times by? Dots. So do you agree there's a dot here?
Yeah.
Do you agree that there's a dot between those two? This is already factored. I've already written it as something times by something else plus something times by something else. What's the biggest chunk that you see is in here and here? What does the highest common factor do? Where does it go? On the side. So you just told me the highest common factor was the a plus 1. So that goes a plus 1 goes on the outside of a set of brackets, and then we have an empty set. Cross them out if you want. Cross out. We just put that on the outside. What's left over? What hasn't been taken care of?
-4
Plus?
plus 2.
Well done. You get marks for that, not all of them, because I can still do something here. I can't add -4 and a, but can I add -4 and 2? So this would go to a plus 1 bracket. What's -4 plus 2? -2 plus a. See how even though this doesn't look like this whatsoever, it's just applying the same principle. And lastly here, I'm trying to fool you. What are we doing with something when you're squaring it? Well done. So is there a long way that I could write this to make it visually look? I could write that as x take 5, bracket x take 5, and you've got the take 2, x take 5 left over. What's the sign in algebra that we don't write? So there's a times here, there's a times there. Is this already factored? This is factored. We've written it as something times something, take something times something else. What's the biggest chunk that's present in both of those things? Good. It doesn't matter which of these you remove, they're literally the same. So I'm going to cross out the first one and cross out the second one. Where does that go? On the outside of a set of empty brackets. What are the leftovers? The ones that missed the bus?
X take 5 to -2.
Is there something we can still do here? A couple of numbers in there, so that would equal x take 5, x. What's -5? Take a further 2.
-7.
Alright, I'll give you time to get those examples. I'm going to stop the